All right, so we're going to start with section 10.1. We're going to go over these problems that you did for homework. Numbers 1 through 4 start on page 323. Number 1 starts out 2.50 moles of zinc, and we want to change that to atoms, okay? So what we want to get rid of course, goes on the bottom, so then those things will cancel. The important thing about this right here is this is a conversion factor, and it must be equal to 1, don't forget, okay? So that has to be equal to 1, otherwise it changes the value of the number, and we don't want to do that. We only want to change the unit itself, okay? So we do the math, and of course this is equal to 1, so we're good there. We do the math and we want 3 sig figs. Why? Because that's what we were given in the problem. So our answer is 1.51 times 10 to the 24th zinc atoms. Okay, whoops. All right, and so then we move on to number 2, and number 2 says, let's see, we are starting with 11.5 moles of H2O, and we are going to molecules. The reason we say molecules instead of atoms or formula units is water, of course, H2O. Those are all nonmetals, and so that is a molecular or covalent compound, and so the smallest particle is a molecule. So we want to get rid of our moles there, so we put that on the bottom. Molecules goes on top. That's the unit we're going to do the math. We want 3 sig figs because that's what we were given in the problem, and we end up with 6.92 times 10 to the 24th H2O molecules. Okay, number 3. Number 3 starts off with 3.25 moles of silver nitrate. Again, we want our moles of silver nitrate to cancel. The reason that we say formula units is because silver nitrate is ionic, and that is a metal and a nonmetal, and so the smallest particle there is a formula unit. Let me get a drink real quick. Okay. So once I do the math, I want 3 sig figs, so I end up with 1.96 times 10 to the 24th silver nitrate formula units. Okay? Now, I want to point out something with number 4, because as I was looking through the work that you submitted the other day to me for your homework, I was noticing that several of you got this wrong because you forgot this step right there, okay? So I want to point that out. So we start with 5.0 moles of O2. As they said in the problem, when they ask you the question, oxygen is diatomic, so we cannot forget that 1 mole of O2 has 6.02 times 10 to the 23rd oxygen molecules. The question was asking you for oxygen atoms, how many oxygen atoms there were. So we get our moles to cancel, we're left with molecules. Well, that's not the same thing as an atom, okay? So we have to say, okay, in 1 O2 molecule, there are 2 oxygen atoms. So when we do that, our molecules cancel, we're left with atoms, which is what we want. We do the math, and we end up with 6.02 times 10 to the 24th oxygen atoms. All right, and okay. Number 5. So we're still on section 10.1. We're on 324. Number 324. Goodness. Hold on one second. Okay. Now, for letter A, 5.75. So here we're going from particles to moles, okay? So we're doing just the opposite of what we were just a moment ago. Same basic principle. We're just going from particles to moles. So we still set it up the same. We want our atoms to cancel, so those go in the bottom. We want to be left with, we want to be left with moles, okay? So we want that to go on top. We do the math. We want 3 sig figs, so we want 9.55 moles of aluminum. And actually, let me go back to this real quick, just one second. Here we only want, this should actually be 6.0 times 10 to the 24th oxygen. Atoms, because we only want 2 sig figs there, okay? I just looked in the book and saw that there were only 2 that they gave you, so I realized that was incorrect. But oddly enough, the answer in the book does have 3, but you only want 2 there. So anyway, just goes to show you cannot always trust even the textbooks that you see. Okay, so we're going to start with 2.50 times 10 to the 20th iron atoms. We want our atoms to cancel, and we want to go to moles. We do the math. We want 3 sig figs. We end up with 4.15 times 10 to the negative 4th moles of iron, or you could write it in standard form, which is 0.000415 moles of iron. Either one is fine. 6a, we start with 3.75 times 10 to the 24th carbon dioxide molecules, because carbon dioxide is covalent or molecular, so the smallest particle there is a molecule, because those are all nonmetals. So we want our molecules to cancel, so that goes in the bottom. We want moles to be on top, because that's what we want to be left with. We do the math, and we end up with 6.23 moles of carbon dioxide. Whoops. Okay, letter B, 3.58 times 10 to the 23rd zinc chloride formula units. These are formula units because, of course, zinc chloride is an ionic compound, and the smallest particle of an ionic compound is, of course, a formula unit. We want our formula units to cancel, so that goes in the bottom. And we have moles on top. We do the math. We want 3 sig figs, and so that takes us to 0.595 moles of zinc chloride. Okay. What was that? Okay, sorry. Oh, right. Number 7. Number 7 says, this is page 324. This is the 10.1 assessment, okay, on page 324. Number 7 says, why do chemists use the mole? Chemists use the mole because it's a very convenient way of knowing the number of particles, whether that's molecules, atoms, formula units, whatever it is that we're dealing with that are in a sample. We can't use mass because mass of carbon atoms would be very different than mass of zinc atoms, and very different than mass of silver atoms, and so on and so forth. So we can't use mass. So mole gives us a convenient way to compare one thing to another. Okay, now number 8 says show a mathematical relationship between mole and Avogadro's number. And of course, that is that 1 mole equals 6.02 times 10 to the 23rd particles, which is Avogadro's number. Okay. All right. Number 9 asks us to provide the conversion factors that are used to convert between particles and moles. Well, we have 2 of them. We have this one and we have this one. Okay. They're used for different things. This first one with the particles on top and the moles on the bottom is for when we are going from moles to particles, okay? This one over here with moles on top and particles on the bottom are when we were going from particles to moles. Now, let me guarantee or assure you that these are not things that I memorize. I try to memorize very little. because there are enough things that we have to memorize. So I just try to give myself little gimmicks to remember things. And the more you use them, the more they just get stuck in your head anyway. But remember the little gift tag approach that I said, kind of think of it like that. When you're writing out a gift tag to somebody, or when you're writing out a card to someone, you might say, to Sue from Bob, or something like that. Okay, so the to goes on top and the from goes on the bottom. Okay, and the unit we're going to goes on top. The unit we're going from goes on the bottom. Okay, all right. Number 10 says, okay, explain how a mole is similar to a dozen. A mole is a quantity, nothing more, nothing less, much like a dozen is, okay? Number 11 says, how does a chemist count the number of particles in a given number of moles of a substance? Well, we take that number of moles and we multiply it by Avogadro's number, which is 6.02 times 10 to the 23rd particles, okay? All right. Number 12. Okay, I want to point out something that I don't believe we've talked about yet. And so I want to make sure that you understand. When you have an element and there's a dash and then a number after that dash, this number that is circled in the red right now represents carbon 12. That 12 indicates the molar mass of that particular isotope, okay? So it's the molar mass of that carbon isotope, all right? So carbon 12 has a mass of exactly 12 grams, okay? And if we are dealing with 0.25 of that, which is a quarter, right? So a quarter of 12 grams is, sorry. Okay, sorry about that. So a quarter of 12 grams is 3 grams, okay? So, so that's why 0.25 of carbon 12 is 3 grams, exactly 3.0 grams. And I maintain those two significant figures there, so that's why that's 3.0 grams, okay? All right, now actually 13, excuse me. Number 13, A, B, C, and D are pretty straightforward there. We're going from moles to particles, just like we did in those preceding problems. So I'm just going to give you a minute to kind of look through those. Here we're trying to get rid of our moles. We're going to atoms. There's your answer there. We maintained those three significant figures. In letter B, we get rid of our moles. We're going to molecules. Do the math. We maintain those three sig figures there. Don't forget your units, okay? Letter C, we get rid of our moles. We're going to formula units. We want 3 sig figs. Okay, and letter D, we're going from moles to molecules. CCH4, that is, of course, all nonmetals, and so those, the smallest particles there, those are called molecules, of course, okay? So we get rid of our moles, we're left with molecules, which is what we're going to, 3 sig figs, which is why we want 3 sig figs there, okay? Okay, number 14. Number 14 asked us to put some things in order. Well, we had 2 things that are in particles, one that was in molecules and one that was in atoms, but both are representative particles, and then one that's in moles. Well, that would be like saying I have 8 of this and 12 of that, and then I have 0.7 dozen of something else, and put them in smallest to largest quantities, okay? Well, I need to transfer, or to convert rather, that mole to particles, okay? So that's what I'm doing here. So it says first convert 3.56 moles of iron. I want to go to atoms, okay? So I do the math, and I have moles of iron on the bottom, and I end up with 2.14. I want 3 sig figs, okay? And so then that allows me to put these things in numerical order, okay? So my order is smallest to largest, 6.78 times 10 to the 22nd molecules of glucose. Then next is 3.56 moles of iron. And we're able to do that because we found that that is equal to 2.14 times 10 to the 24th iron atoms. And then last but not least, the largest is 1.25 times 10 to the 25th atoms. Now, you could have also taken those atoms and you could have, or the atoms and the molecules, and you could have taken them to moles, but that would have meant I had to do two conversion problems, two-dimensional analysis problems rather, and so we're going to work smarter, not harder, and so that's why I chose to take the iron moles and change that to atoms, okay? Now, one thing I would like to remind you to do for homework rather, is I want to make sure that you have done the common assessment for chapter 9, okay, and then make sure that you have completed the QOD, the question of the day, okay? And of course, if you have any questions, please make sure that you are staying caught up with the work. We never know what is going to be the next deciding, or what the powers that be are going to decide next regarding school, okay? And when those grading procedures are going to change, and but I feel certain that we're going to have some changes coming at some point. And I just want to make sure that you guys are staying caught up with everything. All right? Have a great day, and I will see you tomorrow. We're going to start section 10.2 tomorrow, and we go a little bit further with those conversions. Okay, have a great day. Bye-bye.